Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own after a lot of trial and error and struggle, so I'm really happy about this. As you can see, it took quite a few tries. There's some nasty edge cases in there, but I finally managed to do it on my own without any help. So again, I'm really happy about this. So let me show you how I did it. So basically, let's first try to come up with the brute force approach. You're given a string S and you want to find these beautiful indices basically in the order of the instructions. So for I in range length S, it says here if S of I plus length of A is equal to the string you give, and then similarly in B, if S of J plus length of B is equal to B, and if absolute value of J minus I is less than or equal to K, then we append I, right? As long as I is not an answer, because we don't want duplicates, and then we just return answer at the end because it's left to right, it's already going to be in order. So this is originally what I had, but obviously this is n squared and I have to optimize it, so it's not going to work. So as you can see, you're almost there, but you're not quite there. So instead, the idea I came up with is let's just go through every subarray of size A and of size B and keep track of where the start is, right? Because we want to know where the start is. So let's create a dictionary for both, a default dict of list, because we want to keep track of everywhere where it starts. For example, IS starts at index 0, SA starts at index 1, same with B. So for I in range, length of S, and we want to get the lengths of both. A length is length of A, B length is length of B, S length is length of S. So minus A length plus 1 to get all the subarrays of size 1. And we actually want to create a queue, because S of I to A length. So we want to slide the window of size A, and you do that by, let's print AQ first so you can see. Okay, IS, now we just have to shift it to the right by 1. And so if I plus A length is less than length of S, then AQ dot append S of I plus A length. And then we're also going to pop left because we have to slide the window by removing the left character. And now you can see, okay, this is not correct. Oh, sorry, it's that character, not the string, not the substring. So now S of A of W, cool. Now we just have to keep track of AD, a string version of this, and we have to append the starting index, right? So, and then let's just do that for B as well. Same thing, BQ dec S B length, print BQ. So this is n and this is n. It's not n squared though, so that's better. So BQ dot join or BD BQ dot append I. Same thing. If I plus B length is less than length of S, just to make sure we're not going out of bounds, then BQ dot append S of I plus B length BQ dot pop left. Okay, so same thing here. Okay, let's see. Okay, so same thing, sliding the window, and BD dot join BQ dot append I. Same thing, right? So let's actually make this a sorted set so that we can actually use binary search later, because that's the main idea that I came up with. And we want to do add as the API here. Okay, so, okay, cool. Now the real challenge comes, because we want, basically what we want to do is go over, let's say if the string A is inside of the dictionary AD and B is inside of BD, that's the only time where it's possible, right? Because they both have to be in some index and they have to satisfy these constraints using the absolute difference, and that's where it gets tricky. But basically I said for A, for H in AD of A, for L in BD of B, if absolute value of, L minus H is less than or equal to K, then we know we have an answer, right? Which is H, because that's the I here. If H not in answer, then we do that. And then at the end, we can just return answer. So that's a little bit better, but it's still too slow because this is n squared. So since these are already in sorted order by index, let's just use binary search. And let's do a set for this to clean that up. Okay, so let's do scene is set. If it's not in scene, it's going to make things a little better. Add H. So that's still not going to be enough. We have to get rid of this somehow. So almost there, but cool. So now let's just do something. Let's print H and BD of B, because what we want to do is say, is there anything that you do this minus this absolute value is less than or equal to K? If it is, then we can get that index, right? So what we're going to do is a bisect left, because this is already sorted as a set inside of BD of B. And what do we want? We want this minus this is less than or equal to K. So let's do H plus K, right? And that's going to give us the closest element on the left and right, because we want something that's less than or equal to, so we want the closest element. So 0, 1, 2, that's not quite it. Basically through trial and error, I found you have to do -1. So now this is actually B right. B left should be B right -1. Let's print B left and B right just to make sure. So the closest is 0 and 1. 0 and 1, well, not in this case. Cool. So this is where it gets a little tricky, because so if B right is less than length of BD, B, this sorted set, then if absolute difference of H minus BD, B of BR is less than or equal to K, then we have an index. So we can just append H and scene.add H. So, and then we can just continue, hopefully. Okay, so that's a little bit better because we already found the valid index that we need. Oh, wow. Okay, cool. Yeah. So I guess that's it, because we just use the binary search in one and find exactly where it goes in the other. So then that's it. And then this continue makes it so it's not n squared. So again, this took me quite a bit of trial and error, but I did come up with this on my own. So I'm really happy about this, and that I was able to do this without any help, despite it having such a low acceptance rate. So yeah, hopefully the explanation wasn't too bad, and hope you enjoyed. Thank you for watching, and stay tuned for more.